So once we know how to factor, we can actually use that technique to help us solve quadratics. So when we solve quadratics, we're looking for these things called the roots. They are the x-intercepts of a quadratic. So this red line is our quadratic known as a parabola on a graph. And these 2 points, the places that it crosses the x-axis, are known as the roots. You also have them referred to as zeros, or the much longer name, x-intercepts. So these are also the x-intercepts. So this is what we're looking for every single time in our problem. The thing is, at both of these locations, the y-coordinate, both of these locations, the y-coordinate is 0. Since all of our functions have y equals, let's just go with our generic x squared, that's our parent function. 0 for y gets plugged in here, and we solve for it. So in order to solve by factoring, we have to have the quadratic equal to 0. That way we can use this thing called zero product property. The zero product property says that if I have something, some number a, times some number b, and the result is 0, then a is 0 or b is 0. They both could be, but one of them has to be. In order for this to work, one of these numbers has to be 0. It helps us out a lot when we solve by factoring. So the first thing that we do is check, are we equal to 0? We are, we're good to go. We can't use the zero product property because it requires multiplication and there's addition signs here, so we're going to factor this. AC method, 1 times 16, so we get 16. Two numbers that multiply to 16 that are going to add to 10. 8 and 2, so we get p squared plus 8p plus 2p plus 16 is equal to 0. First two have p in common. Next two just have a positive 2 in common. And we have p plus 2 times p plus 8 equal to 0. You might still be thinking, well, we can't use the zero product property. There's these addition symbols. But the multiplication is between these two groups. So according to the zero product property, when this group times that group, times is what multiplies that group, then one of the groups has to equal 0. So in the zero product property says a times b equals 0. Well, a in this case, it's this whole parentheses p plus 2. So we take p plus 2 equal to 0, because either a has to equal 0 or b equals 0. So we put the or there and we get p plus 8 equals 0. This is a one-step equation. We get p by itself by subtracting. You get this p by itself by subtracting 8. And the two answers to this quadratic are negative 2 and negative 8. So we check again, is it equal to 0? Yep. We're going to factor this. 1 times negative 8 gives us negative 8. We need two numbers that multiply to negative 8 that combine to 7. It is just 8 and negative 1. N squared plus 8n minus 1n minus 8 equals 0. I can take an n from the first one. We could take a negative 1 from the second one. Brings us n minus 1 times n plus 8. This group, n minus 1 equals 0, or n plus 8 equals 0. So n is 1, or n is negative 8. If we aren't equal to 0, all we have to do is make it equal to 0. So this negative 8 is stopping us from being equal to 0. So we're going to move it to the other side. And make sure I combine it with its similar terms, its like term on the other side. We still have the 3a squared. Still have the 2a. That gives us negative 21 in this case. Negative 8 and positive 8 create 0. And now we're ready to solve. 3 times negative 21 gives us negative 63. Two numbers that multiply negative 63, they combine to 2. 9 and negative 7. So I'm going to do 3a squared plus 9a minus 7a minus 21 equals 0. That gives us 3a from the first two. And take a negative 7 from the second two. Gives us 3a minus 7 times a plus 3. Now that we have the multiplication here, we can use our zero product property. 3a minus 7 equals 0, or a plus 3 equals 0. So we add the 7, divide by 3, so 7/3. Always simplify your fractions if possible. Not possible in this case, so we're going to leave it as an improper fraction. This is one of our answers. And the other answer is negative 3. We're going to try one last one. Even if it's a different variable on the other side, that does not matter. We want to get it equal to 0. So we add 7r squared, that gives us r squared minus 3r minus 4 equal to 0. It also does not matter if you have 0 on this side. Equations can be flipped either direction and still be the same thing. For me, I prefer having the 0 on the right, so we're going to leave it right there. We need two numbers that multiply to negative 4 that combine to negative 3. It's negative 4 and 1. R squared minus 4r plus 1r minus 4 equals 0. I can take an r from the first terms. The only thing the next two have in common is a positive 1, which is still fine because we are left with our identical binomials. So r plus 1 times r minus 4 equal to 0. Still an equation, you can't just leave out the equal 0. So r plus 1 equals 0, or r minus 4 equals 0. There's our two answers, negative 1 and positive 4.